find our next challenge, we walk up to the Gumshoe Alley PI office and meet Tangle Colebox. Tangle enlists our help to investigate a case involving someone clicking a phishing link. He mentions we will be using the Azure Data Explorer for this challenge, and before we begin, need to create a free cluster. The link provided takes us to the Azure Data Explorer page to create a free cluster. To create a cluster, we need to sign in with a Microsoft account. Once created, we copy the cluster URL from the same page. Then we open the Challenges console, click the Login button, and paste the URL for our cluster. Our Kusto Detective dashboard is now configured, and we are ready to review the first item in our inbox. In this onboarding message, we are given some information about this dashboard. This page also offers a way to quickly train on the basics of the Kusto query language. Our first task is to push the data we will be analyzing into our Azure Explorer cluster. We can simply click the Run button to open our Explorer dashboard and run the given query. This will generate the tables containing the data for this investigation. As this task completes, we get a view of the tables created. These include employees, file creation events, and process events, to name a few. To kick off our investigation, we have to find how many users with the role Craftsperson Elf are working from laptops. To find the correct answer, we first use the take command in the employees table. This will help us better understand what data is available in the table. Review of the results shows the field role is present and contains part of the information we need. Right below it, we see the field hostname, and the naming convention for devices becomes apparent. We craft our query using the ends with KKL filter in order to identify laptops only and the count KKL command in order to obtain our count. We paste our answer and complete onboarding. Our next case arrives and requires us to find more information about the phishing email that was received. To answer these set of questions, we will look at the email table and sample a few events to understand its fields. Hey, that link field looks interesting. Given that we have the phishing URL, we can find the answers to these questions using that field. By querying that field for the domain of the malicious URL, we quickly find the answers to all three of these questions. To solve the second case, we need to find more information about the victim. This information will provide us a starting point and help us pivot around the network as we hunt for badness. To answer these questions, we go back to the employees table and query the information for Alabaster. This record provides all the answers we need. It is important to take note these down as we continue our investigation. To continue progressing in our investigation, we will start honing in on when things happened in order to create a timeline of events. First, we will find the exact timestamp Alabaster clicked on the link and what occurred after. Specifically, we need to find a file created after the Alabaster clicked on the link. To find this event, we look at the Outbound Network Events table and sample it. We quickly notice it contains an URL field. We query this table for any events containing the malicious domain in the URL field and find the exact timestamp of the click. Next, to find the file name that was created after, we will use the File Creation Events table and query it using the timestamp field. We leverage the Kusto between operator and turn the timestamp string into a datetime type using the given function. In this case, we are expanding our investigation time window by 3 minutes. Additionally, our query will filter by hostname, as we already identified that on a previous question. The results include 2 file creation events. The first is for the downloaded malicious document, and the second for an executable named gift wrap. We use this information to solve case 3 and move to our next case. As expected, it seems the attacker established command and control and pivoted around the network. We now need to identify the destination server of the reverse tunnel set by the attacker. To tackle this, we once again expand our timeline using the same methodology as before. This time, we expand to 1 hour after the initial click and find the command which was used to configure the reverse tunnel. This command contains the IP information we were looking for. To find the answer to the next question, we first modify our last query to add more context. In this case, we add the parent process name field to our results, as it will give us more context on how the attacker is operating in the network. The parent of the process used for the reverse tunnel is cmd.exe. Let us modify the query. First, it should look at every process event that occurred after the first click of the phishing link. For that, we replace the between operator with the greater than operator and adjust the rest of that line as needed. Then, we add a new line to filter for events where the parent process name is cmd.exe. After running the query, we get a pretty good picture of what the attacker was up to using the terminal console. This output tells us the command the attacker used to list network shares. It also includes the command the attacker used for lateral movement. In this case, the attacker mapped the C drive of a file server. As case number 5 arrives, it mentions how the attacker used encoded commands to try to hide their maliciousness and requires us to answer 3 questions about those commands. We jump back on Azure Data Explorer and see that our last query also captured these PowerShell encoded commands. As such, we quickly find the timestamp for the first encoded command. The next question asks about the contents of this encoded command. To decode the base 64 string, we will use Kusto's native base 64 decoding function. We feed it the encoded string and get back a strange command in return. Closer analysis shows the strings of the commands are just reversed. Luckily, Kusto also offers the reverse function to reorder strings just like this one. We add a new line to our query and use the extend operator in order to create a new field to hold the value of our reversed string. We run the query and obtain the file name we were looking for. For the last question in case 5, we need to find the domain to which the attacker likely exfiltrated to. We go back to the process events results and find another PowerShell encoded command following the previous one. We use Kusto's base 64 decoding function and obtain a strange-looking set of characters. As we have a set of string we do not understand in front of us, we ask ChatGPT for help. ChatGPT explains the code. The obfuscated code creates an array of characters using ACI values, and it decodes the characters for us. This decoded string contains a path which reveals the destination domain for the attacker's data exfiltration. With this answer, we conclude case 5 and move on to case 6. Case 6 asks about the attacker's last actions. We go back to our original process events query and find the last PowerShell encoded command. Using the Kusto base 64 decode function reveals the name of the executable is Down with Santa, and the used switch is Wipe All. With these answers, we conclude Case 6. The last item in our inbox is a query which decodes the flag for us. We go back to our badge and under Objectives, we enter the flag for Kusto Detective Challenge. See you on the next challenge!